Okay, now when you're creating, apparently with sheet metal, and thin parts, you can simulate it, but apparently, from what they say, but it's still usually better just to convert it to a shell and simulate that because it'll be a lot simpler. And if you think about it, usually the thickness of a thin part isn't always relevant in most simulations. So, and how you do this, let's say, you just go to, work with your surface commands. In fact, we're not going to be dealing with the simulator in this lesson at all. Let's select tangency in this case, so we select the tangent surface, and then that's the thickness we're going to offset because it's 1/8 inch thick plastic. Now the thing about it is that the preview mode doesn't really work that well here. Now I don't know if you can change to like wireframe view. No, it's still not really showing up. You can't really tell what it's trying to do. But it works. It's supposed to preview it on the inside, and usually it does because I already did the handle. But anyway, despite that, anyway, we've certainly created our surface here. So, and you can see that it happens to be midway between the two. Now they do have a command here for actually creating midpoint surfaces, but apparently it'll fail on this body. That's what they say. So they're basically just showing you the hard way, which I guess is going to be a little more robust. So, but anyway, now I got to do a delete body on it. As you can see here. So all this is pretty conventional. Let's go to solid bodies, really. And I don't know if I can do it here or not. I guess I can't. If I can do multiple. Yeah, delete bodies. Okay. Alright, so that'll apply a delete bodies, and I'll just leave the name like that. And did I delete the wrong thing? Oh, I deleted the wrong damn thing. Damn it. Okay, I need to delete the solid bodies, not the surface bodies. Okay. Alright, there we go. So, that leaves us with our surfaces. But, since we use the delete body command, they're still there. We just need to just work with the surfaces. Okay, and I have a feeling they're going to ask us to do an extend surface or something like that. We'll see. Alright, now I'm going to go try to show this plane 3, which is what we're going to trim the surface to. Now, as you can see, it's actually already showing. The problem is that they have it turned off up here, so like I said, the plane's already shown, but you can't see it. So I got to turn it on here. So if you want to view it, and they're just going to go ahead and trim the surface back to this plane, which is probably a pretty good idea. So let's take that surface, okay, and trim it back to this plane here. Let's see. Oh, now trim that. Now we're going to trim this. Okay, and this is the keep section, so we're going to keep that basically, and get rid of that. Now I can go ahead and basically hide this plane. So then we're going to basically extend the surface over, and that should intersect let's see, where is it? Oh yeah, extend surface. Okay. Okay, edges to extend. Should I might need to if I can select, let's see if I can select midpoint, open tangency. Let's see if that works. Okay, yeah, I got it. Now that is what we want to extend. Up to surface is what we want to go to. We want to extend up to that surface. Okay, and then voila, that should do it. Now I got to make sure, since I just did that on my own, I got to make sure that's the way they want me to do it, because I don't want to cause any errors in the simulation, or in a simulation that you'd run. So, okay, they did do it a little differently than me. They wanted to use the linear option and just type in a distance, which also will ostensibly, I don't know. I mean, it looks like their version would have gone through the body, because they just extended it a distance from that plane. It's extended at a distance from that plane 3. So, now they're having to trim it because, it's inside the scoop, I would imagine. Yeah, trim surfaces, so they're having to do it this way instead of the way I did it. The way I did it saved a shitload of commands. Because basically they're just trying to end up with the same damn thing. But if for some reason, your part didn't simulate, maybe you have to do it this way. I don't know. So, I guess we'll try it, because my way is certainly a hell of a lot faster. Anyway. Okay, well, it looks like we are going to run a study after all. So, new study. Create a static study. Surface body 1. Edit definition. Okay, that makes sense. I don't think I can do it at the same time. Oh, I can. Okay, so shell thickness 0.0625. I'm surprised at that because really it's twice that. It's 0.08. I mean, it's an 1/8 of an inch, not a 1/16 of an inch. Guess I shouldn't have clicked on that, huh? Maybe this is what they were talking about, that you could do an offset automatically if this were a solid body, but it's not, so yeah, let me stop out of that since that behaves so squirrely. Let's try it again. Let's see. Okay, okay, let's create mesh. They said make the mesh fine, and here you can see what they're saying. Their mesh parameters curvature-based mesh for the first time. Mesh density, move the mesh folder slider to find. So it should be up here. So okay, basically all they say to do. Okay, so that's what a fine mesh looks like, and again, since it's a surface deal, you can probably get away with that no problem. Now, still, you know, this fine mesh size, you know, if you look at it, okay, if the shovel were still thick, boy, you know, like 1/8 inch thick, these meshes would still be too big to fit inside the thickness of the shovel. So, but anyway, it's a fine mesh size, you know, around the, you know, we're getting higher density around the curves there. So it's a curvature-based mesh. So, okay, now I said these should be sharing common mesh nodes or something. You see, they may not because of the way I did it. You know, I did it differently than they did it. So, you know, because mine aren't sharing compatible nodes. So they did it differently, you know, than I did it, and maybe that's why. That's why I said, you know, this program, you know, who knows. Yeah, because these nodes definitely are not, you know, aligned or anything. So, you know, there must be some difference to the way they did it, you know, by trimming it back the way they did and selecting linear or whatever. So, okay, so basically what they said, you know, is that, you know, it's okay to have an incompatible mesh. It's just you need to define, you know, a surface to edge bonded contact between the two bodies, you know. But if you use a compatible mesh, you know, that's already enforced by default. But, you know, we have an incompatible mesh. Again, the way they did it, they probably did it the hard way just to make sure it would generate a naturally compatible mesh. Because supposedly this, you know, surface bodies, it generates a mesh by default to begin with. But, you know, again, I guess that's affected by the way you create, you know, we join these two bodies up. If we'd done it the way they did it by, you know, using that linear, you know, after we cut the surface with that plane, you know, we had the option to choose linear on the let's see, on the extend surface command, you know, we were supposed to choose linear and not use up to surface and just use the distance based and extend it 1.5 inch, and then they came back and used the trim, you know, command again, you know, to trim the surface, the excess surface away, and apparently that produces a compatible mesh. But like I said, you know, for our situation, that's the end of the study, by the way. They're not going to actually run a study. So, but, you know, for like connections, you know, I don't know how you do it for sure. I'm not experienced enough. Automatically find contact sets. Let's see if it'll do that. Select components or bodies. Okay, I guess I'm going to do that. Retouching faces. Find shell edges solids. find any. Yeah. Well, anyway, I don't know. I mean, you'd think it would be able to find it, you know. Yeah, that should do it. I don't know. I don't know what else that would be. I mean, you know, define a surface to edge bonded contact between two bodies. Okay, whatever. I'm sure that's not what they meant. Anyway. Okay, you can see we got an icon there saying there's something wrong, so you can ask it what's wrong, and it's saying the mesh is out of date. So see if that makes any difference. I don't know. I don't even know if we did that right. I mean, it wouldn't be included. And it's still not aligned, but maybe that's not a big deal. I don't know. Anyway. Okay, well, I tried setting up a study. We'll see what happens with a large displacement flag. But I probably didn't properly constrain my body. I mean, I wasn't quite sure how to go about that. You know, I actually put constraint points like on these two surfaces here. They're pointed in that direction, but I still kind of don't get constraint points in this. You know, really even in the other, I'm still a little confused about it, even in the express version. You know, why these are pointed the way they are, etc. So I have a feeling I'm going to have to end this thing, though, because this is going to take too long, particularly with this mesh density. You know, but I applied a force here, you know, pointing in a negative direction, you know, just 1 pound at that very tip of the shovel, you know. This may not be the best point to apply it, but I don't know. Probably should have just applied a pressure or, you know, pressure or PSI on it. Yeah, it doesn't look like this is going to solve. I'm not going to wait here all week. So. Like I said, I don't know if having a, you know, less fine mesh would improve it or not, because I think it's just my definitions are screwed up. But anyway, you can come back to it, you know. So it's just me playing guesswork with it, because they're not walking me through a study. The tutor's over.